Hey folks, welcome to another episode of AWS On Air. My name is Adrian San Miguel. I'm a principal partner enterprise architect here at AWS, and today I'm joined with some very interesting folks that I think you're going to be talking about, showing, and telling about some of the solutions they've built with us, as well as our friends over at NVIDIA. Today, I'm joined by Kevin and Tara. Say hey, folks.
Hello.
Hi.
Now, random question, and to put you on the spot, are you a dog person or a cat person? Would like
Five cats. Five cats.
Okay.
Yeah.
We got one for the cat. Coffee
Hate dogs.
Oh, we're gonna go out.
I like cats too.
Wow, I am not a cat person whatsoever. I have a long story and history of being bitten on the leg by cats as a kid at my grandma's, so I kind of fell team dog. A little more earlier than I probably should have, but I digress. We're not here to talk about that today. Today, we are here to talk about how you folks at Rescale were able to come together with NVIDIA and AWS and build something pretty cool. And would love to hear, for the benefits of our audience that may not be familiar with NVIDIA and what they do and what you do, would love to hear in your own words what it is that you're doing, why you think this is so cool.
Yeah, I can take that one. So Rescale builds and offers a high-performance computing platform for engineers and scientists, and we make it really easy for them to do their research. So if you think about it, if you're designing a new car or designing new pharmaceuticals, before you start building physical prototypes or running drug trials, you'll typically do a lot of computer modeling and simulation. It's much faster and much more cost-effective to iterate on designs when you're using simulations or AI.
Yeah.
However, building and orchestrating a high-performance computing technology stack to run these simulations, it's really complex. You have to consider everything from all the applications, all the computing hardware that's needed, everything in the middle. Mm-hmm. What Rescale does is we take all that complexity and we abstract it down into a simple point-and-click user interface. It just makes it really easy for those engineers and scientists to go do their work. They don't have to be IT professionals.
That's something I think everybody can appreciate. You know, you're saying, hey, we got to go procure, we got to figure this out. I remember back in my knock days, and my knuckle will still bear the scars of it, of the racking and stacking quick, because you had to go run a prototype, or we got to do a demo, we got a new customer running online. And I remember that lag being anywhere between a couple of weeks to multiple months, depending on what we got and where it was coming from. Now, to be able to take that burden and just completely schlep it off to the side and just focus on pushing the button and going and getting a thing done, I got to say, it's pretty transformational.
Yeah, we agree. We've been in this business for 13 years now, and we're built on AWS. Our customers run lots of their simulations on AWS and the latest hardware architectures. And yeah.
Very cool. Now, I've got another tough trivia question for you, and this is something that my inner nerd always loves to postulate on and argue with folks here. When would you use high-performance computing over generative AI, or is there a place for both of them in an individual workload? Or is it just that kind of, it depends sort of answer?
Oh, I'll take that one. So I have a lot of customers who are dealing with exactly that. And, sometimes they'll even show me slides like where they would have generative AI and they're replacing that. They're just cutting that out with like heuristics that make sense in the specific case that they're looking at. But they're able to use a platform like Rescale to achieve, massive parallelism, to do all of their tests in parallel. So they're still getting speed up. It's just not, and even with GPUs, sometimes it just depends. It really is about what they're trying to accomplish and how, and what's the best way to do that at the level of the science at that particular time. So, certain fields are more advanced in the use of generative AI, but not everyone. And so, sometimes like take these same ideas that you might take for drug discovery and apply them to material science. And no, you're using just good old fashioned AI algorithms or maybe just heuristics. So we can accommodate anything.
That's pretty awesome to hear. And, admittedly, as a self-appointed / kind of forced to be Gen AI SME on my teams recently, I'm not an expert, and I'm still trying to figure this out. And the more I talk to customers and partners, they too are trying to figure this out. It's to better understand when you would use one or another. And I think it's kind of forcing a bit of a reckoning where everybody is having to come back to the table and kind of be humble and say, yeah, I don't understand. Help me figure this out. This is a better way. But if both of you are kind of saying the exact same thing of we've got a thing that helps demystify and make the better decision for you so you can just get right at building the thing and discovering and learning and kind of scratching the curiosity itch. I got to say, that's pretty phenomenal, to be able to break it down to that level of a lowest common denominator so that people just show up with the problem, get to work in the answer, then leave having learned a couple things. I could say that's very commendation worthy. Congrats.
Thanks.
So I've come to understand you might have a little demo, and we would be honored to get to that. Is there anything else that you would want folks to know before we jump into that, though? Tell us a little about what the demo is going to be doing.
Yeah, well, I'll be happy to show a demo. Let me share my screen. This is a demo of BioNeMo, which is a technology put forth by NVIDIA, and it is running on NVIDIA GPUs powered by AWS under the hood. So you can see how we take this entire technology stack and make this simple to use, so that you don't have to know how to put these things together in AWS natively. We do this for you. So yeah, it's now, I have to say too, I'm not a Gen AI expert. So what I did was basically look at the quick start guide from NVIDIA, which is awesome. And it told me exactly how to get started with a little pre-training example, but that's what you're going to see. So I'll just, for reference, there is this little quick start guide that NVIDIA has put together on BioNeMo. And I'll run through quickly, how we do this here. So I have a job running. So you can see like the punchline is it's achieved, before I even start, but I'll just walk you through how you would create this from scratch. So everyone asks about GPUs. So I'll start there.
Yeah.
This is creating a new job. So here, what you can see is focusing on the fabulous set of NVIDIA GPUs that we have. You can pick what you need with whatever interconnect you need for your purpose. So maybe you need a really powerful GPU. Maybe you just need something smaller, to run GROMACS or some other application that has nothing to do with generative AI, but is just molecular modeling or something like that. And you can pick from there.
If I may, it's pretty fantastic to see that drop down and, kind of really show what's under the hood. Some people maybe may have an excess of affinity, for lack of a better descriptor, to an older type of GPU model, or maybe it's the right one for that particular job, but being able to still have that flexibility, I think that's pretty cool.
Absolutely. There's a lot along that performance spectrum. So, and then I'll just show you, like, if you select a particular core type, if you're trying to do this sort of training at scale, you'll need multiple GPUs and they will need a fast interconnect. So just to show you without actually starting the job, just to give you an idea, you can start ratcheting up the number of nodes that you want. And assuming that you can get those, if you have those GPUs available to you at the time that you're trying to run, the cluster will start with the correct networking configuration. When Kevin was saying we try to make this easy for you, that's part of it, right? All of the networking fabric, making sure that MPI connectivity is set up correctly for, direct connect and CUDA. All the drivers are all in place. All of that is done by us to make sure that that works. So
as someone that recently kind of helped a peer set up CUDA drivers within the last 2 weeks, actually, has greatly appreciated, and that was like 4 hours of my life I will never get back. So if we can get that link thrown into the chat, that'd be awesome. That'd be good for me selfishly to have that to dog here. But I'm sorry, I digress.
Sorry, which link did you want? The
NVIDIA Quick Start would be fantastic.
NVIDIA Quick Start. Okay, so I'll just grab that and put that in here.
Great, thank you.
Yep, absolutely. So I'll just pick, like, let's just do one node here, and then let me go to the software. So here you can see that, like, I've got the NGC catalog, but I've also got a lot of other things, right? So there's 1,000+ applications here for all different domains of science and engineering that Rescale supports. So when I click, for example, on NGC catalog, you can see for each of these applications, we kind of have a template that shows you, what's in the quick start, like what do you need to run? What do you need to do? And the first things here, basically, you need to pull the container and then you need to run it with the right options.
Okay.
So this is where I will fill in, my container. Let's go there. And then my run command.
Okay.
I have a little script which will go through the 2 commands to pull the data and do the training. So this is the BioNemo script. It looks a bit scary, but it's all from that doc. So, and then you need an NGC key and you need NOR code. So these are here, and I guess because it's recorded, I won't pull them to show you, but it does save like my previous value. For example, I just won't show my key here.
Yeah, that's
So you have to edit that out later. But that is how you set this job up. And then for any inputs, I can upload the files that I want from my computer and load them up and then go. And you see, I can submit, there's SLAs that are provided for certain instance types and things like that. GPUs, as everyone knows, are a little harder to get. So it might be a little bit longer before you're able to find one. But now it's going to start. It won't run because I haven't put my key in there, but I can show you the running one.
yeah.
And yeah. So the other thing I want to point out too is like under the hood here, this is all AWS EC2 instances. Those files I uploaded, those are going to S3 object storage.
Okay.
And if you need like a lot of storage, fast, high performance file system, we support FSX Lustre. So you don't even have to even attach it. It's just going to be there for you. So you can start your cluster and it will be there across your entire workspace. So everybody can collaborate and share data across all of that. And so that's really, it's done transparently and kind of in the way that makes sense. So
yeah, absolutely makes sense. If I've got an EKS cluster, I need to be able to attach this to, say that Lustre file system and start munging out things. Being able to do that and just kind of like hand that commonplace dumping ground, for lack of a descriptor, that's huge. I remember the old, MS SQL, hey, here's our scratch space, or hey, this is where the backup of the databases or the flat files are going. This is this on a much more sophisticated and really cool scale, to be honest with you.
Yeah, that's what everybody wants. I'm going to quote you on that. The dumping ground. That's exactly it. Yeah, I keep telling people that. But anyway, just to highlight here, this is training slowly because this is a V100 that I did it because it was just I set it up before and it's a cheaper thing. So, but you can see that you're getting a live tail on the Unix tail commands. Of the log files and the output as this goes. If you don't like this, we also have ways to bring up a workstation so you can have a graphical user interface using nice DCV, for example. Another great technology from AWS. And you can also bring up a Jupyter notebook and work interactively with a Jupyter notebook to do your training and stuff. So it just depends, how you like to access it, what way you want to do it. A lot of people like the batch approach just because they're trying to maximize the use of the compute time and don't want to pay for a cluster to be up while you're doing things interactively. But otherwise, that's it.
Awesome. And, kind of chuckle at the end there, wanting to maximize the time, do things in batches. Like to bring that to, my own notoriously bad attempts at sometimes multitask. You want to make the most of the time. So you just go and use the right thing for it so that you get your time back and can go and focus on the other things instead of sitting there hitting X a bunch of times or just running things in serial. I mean, that's pretty awesome. Well done.
Good.
Awesome.
Glad you like the demo.
Yeah, it's great. So if I'm a curious person and want to continue to learn more and do more, where can I go get more information? Would love anything that you can share with us in the audience as a parting thought.
I'll let Kevin take that one.
Okay.
Yeah, you can visit our site, www.rescale.com. And you can, on the site, you can fill out a form to get in touch with a member of our team, request a demo. And that's probably the, easiest way for a broad audience to sort of start engaging with us.
Okay, awesome. I would assume that because you've partnered with both NVIDIA and AWS, is there like a partner page that folks can go click on to learn more about that?
There is on our site, there is a tab for partners, and we do have an AWS partner page where you can view case studies. You can read a little bit more about our integrations with AWS. And so that would be another great place to explore how we work together.
Awesome. Thank you so much for your time. Really appreciate y'all coming on with us today. It gotta say, it's definitely going to be interesting to see what folks are going to use the technology for. I look forward to reading some of those case studies here after I get the opportunity to do so. And I look forward to our paths crossing in the future. For the rest of our audience, please bear in mind there are a ton of other shows. We do have our weekly AWS On Air show, as well as Lockdown, Game Day, and a variety of other shows that are absolutely just as action packed as this, with hosts far better than I am. And we are absolutely here for you, the audience, to help answer your questions and help you get things done. Again, my name is Adrian. Thanks so much for hanging out with me today, and we'll see you next time. Thanks.